In this video we have the integral of 2x over x minus 3 to the second power. And this is an integral that you can do, well, at least two ways. First way you might consider is partial fraction decomposition. We have it in the case where we have linear factors that are repeated. That would work. Like I've mentioned before in other videos, my go-to method is the U-substitution, unless it doesn't work. In this case, it will work. We'll let u equal to x minus 3. Then du would be the derivative of x minus 3. That's 1, 0, so that would be dx here. So let's rewrite this in terms of u. So this would be the integral. Everything involving x has to be replaced by a u. So obviously the x minus 3 in the denominator, that's going to be your u. The dx here is the same as the du. So that's taken care of. And for the x, we can use the same u-substitution, except in this case, we solve for x. Let's take the 3 over, and we get x can be replaced by u plus 3. So for the x, I'm going to have a 2 multiplying the u plus 3. And then I'll multiply through by the 2 here, and then divide by the u. So it'd be 2u here, and that's over u, so the u would cancel, so this will leave me with a 2. And then 2 times 3 is 6, and that's over the u. And this, of course, was a u, x minus 3u. This is a u squared here. So again, 2 times 3 is 6. That's over u squared. And this is du. You can also think of 6 over u squared as 6 times u to the second, negative 2. And then we're ready to integrate here. Integral of 2 with respect to u is 2u. And then for this one here, 6u to the negative 2, add 1 to the negative 2, I get a negative 1. Divide by that, that's be a negative 6 here. And this will give me u to the negative 1, plus the constant of integration. So 2u minus 6, u to the negative 1, plus c. Then we just go back to the original variable. And a quick mistake here. So I have changed this to u squared, so this is going to be, then u over u squared will be 2 over u. So that'll make a difference here, because now for the integral here I have integral of 2 over u du, so that's going to be your natural log here. So that becomes a natural log of u, and it's absolute u. So this will be, so then we go back to the original variable, so this will be 2 ln, and u is x minus 3. Then it's minus 6, u to negative 1, I can put it down in the denominator, and then replace the u by x minus 3, plus the constant of integration. So using the u-substitution here, we get final answer of 2. We get 2 natural log of absolute x minus 3 minus 6 over x minus 3, plus the constant of integration. So that's the answer using the u-substitution. But like I said, the partial fraction decomposition will also work. So the idea then is to take this integrand 2x over x minus 3. Quantity squared has repeated factors. This will be your setup, 2x over x minus 3 squared. And then it'd be constant a over x minus 3. Because it's repeated, then we have another one, constant b over x minus 3, quantity squared. And then we clear the fractions by multiplying by the LCD, which is x minus 3 quantity squared. So that's going to clear. When I do that, this is going to be canceled out. I'm going to get 2x. Then multiplying by x minus 3 squared here, 1x minus 3 under the a cancels. It leaves me with 1 in the numerator, so it'll be a times x minus 3. And for the second expression on the right here, x minus 3 squared cancels, I get the b. And then I just, several ways you could do this. I could just pick values, so convenient values. Pick x to be 3, wipes out this. Get 0 there. Then 3 times 2 is 6, so b is 6. If I pick x to be 1, then on the left side I'll have 1 times 2 will give me a 2. On the right side, it'll be 1 minus 3 is a negative 2, so it can be a negative 2a. We already know b is 6. Take the 6 over, it gives me 2 minus 6 is negative 4. divide by -2, we get a to be 2. So then this would be written as the integral a is 2 over x minus 3. And then the b is 6 over x minus 3 quantity squared. Integrate this, you can see we're going to get the same thing. Got 2 over x minus 3. That's going to come out to a 2 out here in front. And that's just going to be your ln of absolute x minus 3. Then for the next one, again, I can take this to the numerator, be x minus 3 to the -2, add 1 to the exponent. That's going to be a -1, and that divide minus 6 out here. And then this would be x minus 3 to the -1, plus your constant of integration. Same answer. You could bring this to the denominator and just make it a +1 here, so it'd be 2 natural log of absolute x minus 3 minus 6 over x minus 3. Thanks for watching. We'll see you next time.